right, we're solving rational equations. This is 14.6. And our goal in solving rational equations that differs from our goal in simplifying rational expressions. So I want to put our goal is to eliminate the denominator. Okay, we can't solve an equation when the denominator is has a variable in it. So we need to get that denominator to be eliminated so that we can figure out what x is. But before we start, because we cannot divide by 0, the first thing that we have to do is to find our restrictions. So any denominator that has a variable in the bottom, we are going to set not equal to 0. And of course, if we solve this one in both situations, it says that x cannot be 0. And that's my restriction. So if I go through and solve this equation and I get a 0 as a solution, I have to toss it out because it's not truly a solution if it is also a restriction. The next step I need to do is to find my LCD. And remember, my LCD has to have all the denominators represented, the greatest number of times it appears in any one factor. So x obviously just factors as x. 8 is 2 times 2 times 2, and 4x has an x and 2 2's. So if I get my highlighter, I need 1x and 3 2's. So I am going to multiply every term by the LCD, which is going to be 8x. So I'm actually going to write it out, then I'm going to show you how to do a shortcut. I'm going to take 8x times 3 over x plus 8x times 1 over 8 is equal to 8x times 13 over 4x. And then I'm going to see this x eliminates this x, and now I have 8 times 3, plus this 8 eliminates this 8, and I have x times 1, and these are eliminated, and 4 goes into 8 and leaves me 2. So now I have 2 times 13, which is 26. So then I just have a regular linear equation that I am going to solve by subtracting 24, and so x comes out to be 2. And since 2 is not a restriction, then this is my actual solution. And so here's a good little checklist of how you're supposed to solve an equation. I always find the restrictions first, and then I find the LCD, but those are the steps that you're going to follow in the process. Checking is extremely important when we come to rational equations, because roots that appear to be solutions but are also restrictions are called extraneous roots. Okay. All right. Now in this instance, this is a ratio, two ratios which set up equal to a proportion. So in this case, I could cross multiply, but I can also follow the procedure like I did prior. But before I start anything, I have to figure out my restrictions. So I am going to write restrictions, taking x plus 2 not equal to 0. So that says x cannot be negative 2. And then I'm going to take the x squared plus 7x and factor it. So x cannot equal 0, and x plus 7 cannot equal 0, which says x cannot be negative 7. So you'll have a restriction box, you'll have an x cannot equal, and then you will have a big box that you will have to fill in the 3 restrictions, negative 2, 0, and negative 7. And it doesn't matter what order that you put them in, okay? Then I can come over here and find my LCD. I need, and sometimes it's nice to highlight it, and I've already factored it. I need an x plus 2, I need an x, and I need an x plus 7. So that's what my LCD is going to be. X times x plus 2 times x plus 7. I always put the single variable in front. I could cross multiply, or I could multiply by the LCD. If I multiply by the LCD, it looks like this. And then I'm just going to make sure that this is factored. So now what happens is this x plus 2 cancels this x plus 2, and I have x times x plus 7 times 1. This x cancels this x plus 7 cancels this x plus 7, and so I have 6 times x plus 2. Go ahead and distribute, and so I get x squared plus 7x is equal to 6x plus 12. It's a quadratic, so I need to subtract the terms on the right over to the terms on the left. So I get x squared plus x, and then let's go ahead and subtract the 12. So I'm going to come up here. So I get x squared plus x minus 12 is equal to 0. I have to factor it so that I find factors of negative 12 that make positive 1. So that says x plus 4 equals 0. So x is negative 4. And x minus 3 equals 0. So x is 3. And since neither one of those is a restriction, then those would be my two solutions. X is negative 4 and x is 3. Now notice the next one is not a proportion, and sometimes students try to cross multiply, but because of this 1 right here, this makes it not a proportion. So I'm going to start by finding my restrictions. And so I'm going to take x minus 4 cannot equal 0. So x cannot be 4. And x plus 8 cannot equal 0. So x cannot be negative 8. Then I find my LCD. And my LCD is going to be x minus 4. I need one of those. And x plus 8. I need one of those. So I'm going to multiply every term by the x minus 4, x plus 8. So it gets a little cramped here, but you can do it this way. I'm going to show you kind of a shorthand. Is I'm going to write x minus 4, x plus 8, x minus 4, x plus 8, and then x minus 4, x plus 8. So I'm writing the LCD next to every term, and then I'm going to get a different color. This x minus 4 cancels this x minus 4. Be careful because that is a negative 4, and then I have to multiply it by x plus 8. And then I have 1 times x minus 4, x plus 8, and then I've got minus 2, and the x plus 8's cancel, and I'm left with x minus 4. So now I've got a lot of distribution and cleaning up. So negative 4x minus 32. FOIL this out, x squared. Outer is 8x, inner is negative 4x. Last is negative 32 minus 2x plus 8. Collect all my like terms here, so I get x squared. 8x minus 4x is 4x, and 4x minus 2x is 2x. And then negative 32 plus 8 is negative 24. and I get negative 4x minus 32. And since my x is, my x squared is positive, I want to make sure that I leave it positive, and I'm going to just move everything over to the right-hand side. So I'm going to add 4x, and then I'm going to add 32. And so that gives me 0 equals x squared plus 6x plus 8. So we factor it. I'm looking for factors of 8 that make 6. That's positive 4 and positive 2. Then I set each of these factors equal to 0. And I get x is negative 4 and x is negative 2. And since negative 4 and negative 2 are not restrictions, then they are true solutions. 4 was a restriction, but not negative 4. Okay? All right, so now let's go to this next one. So here we've got denominators, x minus 2's, but then I've also got that x. So I'm just going to state my restrictions. First, x minus 2 cannot equal 0, so x cannot be 2. And then I've got this x that's a different factor, and so x cannot be 0 as well. My LCD is just going to be x times x minus 2. I need one x because that's in one of the denominators, and I need one x minus 2 because that is represented in the denominators as well. Okay, so I only need one of each. So when I multiply by x times x minus 2, x times x minus 2, x times x minus 2, and x times x minus 2, what you see happen is the x minus 2's cancel, and I have x squared. This and this cancels, so I have x minus 6. The x minus 2 cancels. I get 5x times x, or 5x squared. The x minus 2's cancel, and I get negative 10x. Again, since my x squared is positive on the right, I'm going to move everything over to that side. So I'm going to subtract x squared. I'm going to subtract x, and I'm going to add 6. So this gives me 0. 5x squared minus 1x squared is 4x squared. Negative 10 minus 1 is negative 11x plus 6. So here I'm going to have to do a little bit of work to factor this. I am looking for factors that make positive 24 that add up to negative 11. And that would be negative 8 and negative 3. So if I did my box, I'm going to have 4x squared, 6, negative 8x, negative 3x. And I'm going to factor out a 4x and a negative 3. And then I'm going to factor out an x and a negative 2. So 4x minus 3 times x minus 2 is equal to 0. 4x minus 3 equals 0. 4x equals 3. So x is 3/4. And then x minus 2 equals 0, so x is 2. And now what you have to do is you have to look that x cannot equal 2 because that is a restriction. So we have to toss this solution out. So my solution is only x is equal to 3/4. And if you put 2 in there, you will lose partial credit because you did not stop to check that answer. Okay, so this one is very similar. What you might notice is once you do your restrictions, so we always start with that, And again, we've got x minus 2 cannot equal 0, so x cannot be 2. And then, of course, we have x cannot equal 0 as well, since we have that simple single variable out in front. So my LCD is x times x minus 2. And what you can do, instead of writing all of the LCDs next to each one, you can look at the denominator. The x minus 2 cancels out of the LCD, and what's left is an x. So x times x is x squared. So you could, you could write that and then bring it down. Okay, this one, the entire denominator is going to cancel because that is the LCD. And so I get 4x minus 4 equals the x minus 2 it cancels, and what's left is the x, so that makes 6x squared. And then minus the x minus 2 cancels, and what's left is x, so I get minus 8x. That might be an easier way for you to do it, just as long as you don't get confused that you have to do it for each fraction, okay? Then we're going to subtract x squared. We're going to subtract 4x, and we're going to add 4. So now I have 0 is equal to 5x squared. That's going to be negative 12x, and that's going to be plus 4. So I'm looking for factors. Well, I'm going to do this one by trial and error, guys. You can certainly do your box, but I know the only way to make 5x squared is 5x times x. And if I put, let's see, I think if I do 2 times 2, that gives me 10. That gives me 2. That's going to make negative 12. So I want them both to be negative. And so then I'm going to take 5x minus 2 and set it equal to 0. So 5x equals 2. So x is going to equal 2/5. And then I take x minus 2 equals 0, and that says x is 2. But if I look, 2 was a restriction, so I have to throw that out. So my solution is only x equals 2/5. Okay? All right, let's try this one. Now, these two are very similar. And so once you do one, you're going to kind of get the hang of the other. The first thing I would do is make sure that everything is factored, so that when I look at my restrictions, now x squared is just x times x, and then this is x times x minus 3. So my restrictions are as follows. I have x plus 3 cannot equal 0, so that says x cannot be negative 3. X minus 3 cannot equal 0, so x cannot equal 3. X cannot equal 0, and I think that's it. Now, because I have x squared is just x times x, each one of those x's cannot equal 0. So my restrictions are going to go in this box. And so I'm going to have negative 3, positive 3, and 0. Okay? Now, my LCD, I need 1x plus 3. I need 1x minus 3, but I need 2x squareds. Okay? So I'm going to write my LCD. I'm going to put it over here. My LCD is going to be x squared times x plus 3 times x minus 3. So if I write that, x squared, x plus 3, x minus 3, these are going to cancel out, and I'm left with 2x squared equals x squared, x plus 3, x minus 3. The x squareds are going to cancel, and so I get x plus 3, x minus 3. And then I'm going to write x squared, x plus 3, x minus 3. And x minus 3 is going to cancel, and one of those x's is going to cancel. And I'm left with x times x plus 3. So now when I FOIL this out, I get x squared minus 9. When I distribute, I get x squared plus 3x, and that equals 2x squared. Collect my like terms. So now I have 2x squared plus 3x minus 9 is equal to 2x squared. And what happens when I've got 2x squared on one side and 2x squared on another side, they cancel each other out. And so now I'm going to move the 9 over. So I get 9 is equal to 3x. Divide by 3. And so my solution is x equals 3. But notice that x equals 3 was a restriction. So this has no solution, okay? So we have to do all that work just to toss it out and say it is an extraneous root. We solved it correctly, we found the answer, but then when we look, the answer happens to be a restriction. So this next one is going to be exactly the same. The numbers are just slightly different. So I'm going to say my restrictions. This, remember, is x plus 5, x minus 5. And this is going to be x times x minus 5. So if I have x plus 5 cannot equal 0, that says x cannot be negative 5. If I have x minus 5 cannot equal 0, that says x cannot be 5. And then, of course, x can also not be 0. So my restrictions, if I list them in my box, are going to look like this. Negative 5, 0, and 5 in any order, okay? My LCD, I need 1x plus 5. I need 1x minus 5, and then I need 2 x's to make x squared. So if I multiply x squared, x plus 5, x minus 5, x squared, x plus 5, x minus 5, x squared, x plus 5, x minus 5. And I get my pen. X plus 5 cancels, x minus 5 cancels. I have 4x squared. X squared cancels, and I have 2 times x plus 5, x minus 5. Plus the x cancels 1x, and the x minus 5 cancels the other. So I have 2 times x plus 5. Clean it up. This is going to FOIL to x squared minus 25, which I'm then going to have to multiply by 2. And this becomes 2x plus 10. So 2x squared minus 50 plus 2x plus 10. And so let's collect our like terms. Negative 50 and positive 10. That's going to make negative 40, but let's put it in descending order. And that equals 4x squared. So this one, the x's do not cancel. X squareds do not cancel. So I'm going to move everything over to the left. So I get 2x squared. Go ahead and subtract the 2x. Go ahead and add the 40. Pull out the GCF. X squared minus x plus 20. Factors of positive 20 that make negative 1. It's going to be negative 5 and positive 4. Of course, we only set the factors that have variables equal to 0. So that says x is 5. And then we set x plus 4 equals 0, and that says x is negative 4. But if I look, 5 was a restriction, so we have to toss that one out. So my only solution is going to be x is -4. All right, the last two problems of this section, a little bit intense with the, finding the LCD, but not too bad because you're going to have to factor it. Oh, you know what? I think I did something wrong here. Oh, I did. Sorry. This should be 2x. Ugh. Darn it. I made a mistake. All right, let's go back here. I missed that x. It should be 2 times x, and that's going to make it 2x squared plus 10x. All right, so let's start over here. Let's do this. Made a mistake. That happens. I was like, what? I thought it was very similar to that last problem. It's kind of weird that it worked out like that. Whoops. Okay, so let's do this. Okay, so let's start, and we get the x, so we get 4x squared. That was correct. We get 2x plus 5, x minus 5. And then we have 2x times x plus 5. I missed that last x there. So we get 4x squared equals 2 times x squared minus 25 plus 2x squared plus 10x. So 2x squared minus 50 plus 2x squared plus 10x is equal to 4x squared. Combining, I get 4x squared minus 50 plus 10x. And then these are going to cancel. So I have negative 50 plus 10x. And if you move the 50 over, and then you divide by 10, you get x is 5. So 5 is a restriction, so it cannot be a solution. So we would say no solution. Okay? All right, sorry about that. All right. Next one. So this one, we have to make sure that our denominators are completely factored. So the good thing is that when you factor this one, it's going to be x plus 5 and x minus 1. So first, let's find our restrictions. X plus 5 cannot be 0. So that says x cannot be negative 5. X minus 1 cannot equal 0, so x cannot be 1. My LCD is just going to be the combination of those two factors, x minus 1 times x plus 5. So if I multiply by those x plus 5, x minus 1, x plus 5, x minus 1, x plus 5, x minus 1. In any order, it doesn't matter how you write it. So the x minus 1's cancel, and I have x times x plus 5 minus the x plus 5's cancel and the x minus 1's, but you have to be careful because you have to put parentheses around that numerator because you're subtracting everything. And then the x plus 5 cancels, and I have x plus 2 times x minus 1. So we've got a lot of cleaning up to do here. Distribute. Make sure you distribute that negative sign. FOIL, x squared. We get negative x, positive 2x, and negative 2. Collect our like terms. X squared plus 2x minus 1 is equal to x squared plus x minus 2. And so the x squareds are going to cancel because I've got x squared on each side. Then I'm going to subtract x. So I get x. I'm going to add 1. So I get x is -1. And that is a solution because the solutions were +1 and -5. Okay? All right, the last one, we've got y plus 5 times y minus 2. That's the factorization. So my restrictions, y plus 5 cannot equal 0. So y cannot be -5. Y minus 2 cannot equal 0. So y cannot be 2. My LCD is just going to be y plus 5, y minus 2. So I write that, y plus 5, y minus 2, y plus 5, y minus 2, y plus 5, y minus 2. Get your pen. Y plus 5's cancel, y minus 2's cancel. So I'm left with 4y squared. Y plus 5's canceled. So I'm left with y plus 1 times y minus 2. Y minus 2's cancel, and I'm left with 3y times y plus 5. 4y squared. Foil this out. We get y squared minus 2y plus y minus 2 plus 3y squared plus 15y. 4y squared. We got y squared and 3y squared, so that makes 4y squared. -2y and positive y makes -1y plus 15 makes 14y. And then we've got, is that -2? Yep, minus 2. All right, so the y squareds, 4y squared is going to cancel out 4y squared. So we get 14y minus 2. We're going to add 2. We're going to divide by 14, which is going to simplify to 1/7. And since 1/7 was not a restriction, then this is my only solution. So that finishes 14.6 with the solving of rational equations.